this video, we're going to take a look at input devices, similar to GCSE, but a little bit more detail is needed. So you need to be able to define a range of input devices, identify them, and explain where and why they are used. Now, there's hundreds to go through, so I'm just going to go through the most popular ones, but to make sure you've got a good understanding of each of these and you'll be absolutely fine. So we've got two types. We've got manual and automatic input devices. So a manual input device transfers outside data. So that could be you click at a mouse or a sensor. That would be an automatic one. From the outside world to the computer. However, mice and keyboards, keypads, microphones, touchscreens, anything you've got to as a human touch and use is a manual input device. So we've got keyboards, you've got to type, you've got to click on things. So ATMs have them, keyboards, specialist keypads like McDonald's, for example, they'll have a specialist keypad to order burgers and things. So they're all manual input devices. Touchscreens, you could argue that they're both input and output, but they still take an input. Pointers, nice and easy. Mice, tracker balls. You could even argue graphic tablets can be used as mice. So it allows you to click on things on a screen. Obviously, a tracker ball means you can move the mouse without actually physically moving the mouse, which some people prefer it because it saves desk space. Personally, I can't stand them. Interactive whiteboards like you see in school. They might be a touch screen, it might just be a projected image, but usually they have some form of either a sensor tracking where your hand is, or they'll be a touchscreen device allowing you to broadcast big presentations to lots of people, such as school. Then you've got automatic input devices. So these are ones that don't take human intervention. So we've got barcode readers are one. So there's two sort of types. You get ones that are specific for warehouses and retails, which use a different format. We've then got another type of barcode reader, which is using like transport and shipment. You don't really need to know the difference between these two. You just need to know what a barcode reader does, where it looks at essentially the gaps in between big black lines. Like if you look at the back of a DVD or anything from the shop, you can see them, and it converts that to a binary number, which identifies a product uniquely. We've got QR code as well, where they're barcodes that essentially are put into a 2D format that we can read on a smartphone, which can be to anything. So it could link it to a website, a YouTube channel, a form, a ticket, something like that. Then we have scanners, which take essentially something from the real world and converts that to an image. So it could be a fingerprint scanner to get biometric data. It could be one that's used on a printer that could be used to photocopy a piece of paper or scan it into the computer. Really useful for scanning your exams. Then we can use the computer to mark your papers, for example. You might have facial recognition that uses a camera. So when you go through the travel gates at an airport, it scans your face. You don't need any human interaction for that. You can just go through on your own when it works. Then we've got 3D scanners, which can be used to use technology called tomography, which essentially slices an image up into very thin slices, so we can use it in 3D printing or to get a good scan of what something looks like in a 3D format. Sometimes as well, we want some data that's obtained directly through the use of sensors. So you might have a temperature sensor, you might have a moisture sensor that can automatically either send data or be using a control system to turn a fan on, for example, if it's too warm. That's when you have a control or a monitoring system. So a sensor is just any hardware device that can measure a physical property, example, temperature or pressure, from real world surroundings, and then we can actually use them in a computer. So we take analog data and turn it into digital data. So again, knowing a range of sensors is going to help. So you might have a gas sensor that maybe measures oxygen levels or carbon dioxide levels, infrared to check motion or if something's warm, light to see how dark it is, temperature to see how hot it is or cold it is, pressure, pH or acidity, magnetic field, humidity, sound detectors. There's lots of different sensors we can use, far too many to go through, but having an understanding of how some of these work. Think about a greenhouse might have a light sensor, so it turns on some UV bulbs when it gets too dark. It might have a temperature sensor, so it turns on fans or open windows when it gets too hot or cold. And you might have a moisture sensor, and it might turn some sprinklers on. They're all quite useful because it means you can manage your plants or your vegetables without actually having to have a farmer or somebody go and work there, which saves money. So you have a monitoring system and you have a control system. A monitoring system just reads data and plots things like graphs. So I might want to measure temperature of a volcano. So I have a sensor up there. It saves a human going up there, and it means it's going to be nice and safe, but I can plot a graph on how hot it is or anything like that, just in case I need to get people out of the way of a volcano. So a monitoring process will constantly send data. We convert that data from analog, to digital. Or if it's already digital data, if it's been sent on something else, then obviously we don't have to convert that. So the computer will then check the oxygen level, let's say, against a preset value. If the oxygen is, say, less than 15%, it might warn somebody, but it won't do anything because it's a monitoring system. A computer might check pH levels against set values. If the pH is less than 6 or greater than 8, then it might warn somebody to do something. And that monitoring system continues until it has been switched off. A control system actually changes that property. So if you've got something connected to aircon, for example, if it gets above 25 degrees, your fan might turn on. These can be designed by using schematics, so you can see that the sensor goes through an analog to digital converter. That digital value is sent to the processor where it checks it against those settings you've set. It then uses a DAC, so digital to analog to air converter, to turn an actuator, which is usually a motor, which could be a fan, and then that turns on. So we've got the idea of a temperature sensor going to the ADC, going to the microprocessor, getting converted back, and turning the motor on for a fan. A little bit over 5 minutes, we're looking at about 7 minutes now, but those are your basics of input devices and looking at monitoring and control systems. I rushed it a little bit to try and keep it nice and brief, so please go back through the video again. It helps me, and pause at a certain points, make some notes. But that's that, and I will see you in the next video. Please like and subscribe, it does really help, and I'll see you in the next one.